Welcome to today's ArXiv CS Digest for May 13th, 2026. We received 981 new computer science papers today across 65 subfields. Let's dive into the top picks. Trend 1 of 5, AI System Analysis and Design. This trend unifies research on understanding, designing, and ensuring properties of AI systems and their underlying algorithms. This cluster covers 172 papers. Representative work includes what is learnable in Valiant's theory of the learnable, mechanism design for decentralized risk detection, strict propriety, network coalitions, and the backfiring mandate, and do activation verbalization methods convey privileged information. Trend 2 of 5, long context LLM capabilities and safety. This trend advances long context LLM capabilities, addressing their limitations and ensuring safety and reliability in diverse applications. This cluster covers 217 papers. Representative work includes Warden, Endangered Indigenous Language Transcription and Translation with 6 hours of training data, QLAM, a quantum long-attention memory approach to long-sequence token modeling, and training long-context vision language models effectively with generalization beyond 128K context. Trend 3 of 5, Foundations of Scientific Machine Learning. This trend integrates scientific principles with advanced machine learning to build robust, reliable, and theoretically grounded models for scientific discovery. This cluster covers 236 papers. Representative work includes quantitative linear logic for neurosymbolic learning and verification, topology-preserving neural operator learning via Hodge decomposition, and towards a generative protein evolution machine with deeplearning. Trend 4 of 5, Generative vision and 3D applications. This trend leverages generative vision and advanced 3D techniques to synthesize, understand, and apply complex spatial data. This cluster covers 209 papers. Representative work includes RDemesh, video-guided 3D animation via rectified dynamic mesh flow, unlocking patch-level features for clip-based classic incremental learning, and OmniLiDAR, a unified diffusion framework for multi-domain 3D LiDAR generation. Trend 5 of 5, AI agent design and evaluation. These papers unify research on designing, evaluating, and understanding the impact of AI agents across diverse applications. This cluster covers 147 papers. Representative work includes EVA Bench, a new end-to-end framework for evaluating voice agents. Good agentic friends do not just give verbal advice. They can update your weights and harnessing agentic evolution. Up next, our first paper out of 5, Multipath Memory Access, Breaking Host GPU Bandwidth Bottlenecks in LLM Services by Lingfeng Tang and Guochun from Hunan University. Let's break down its key contributions. The authors introduce Multipath Memory Access, MMA, a novel scheme designed to enable efficient multipath data transfer between the GPU and host memory. This contribution addresses the critical bottleneck of limited PCIe bandwidth in large language model services. This contribution focuses on MMA's seamless deployment mechanism, which utilizes dynamic library injection. The system allows LLM applications to leverage MMA's benefits without requiring any modifications to their existing codebases. The system demonstrates a significant improvement in data transfer bandwidth between the GPU and memory, achieving a peak of 245 gigabytes per second. This represents an impressive 4.62x speedup compared to native single-path bandwidth. The authors show that MMA significantly enhances end-to-end LLM serving performance. This includes reducing the time to first token, TTFT, by up to 2.38x and decreasing model switching latency in VLLM sleep mode by up to 2.48x. Up next, our second paper out of 5. Copyright laundering through the AI Ouroboros, adapting the fruit of the poisonous tree doctrine to recursive AI training by Anirban Mukherjee and Hannah Hanwen Chong from Aviam Holdings. Let's break down its key contributions. The authors introduce the concept of copyright laundering, explaining how multi-generational AI training pipelines, termed an AI Ouroboros, create an evidentiary blind spot that makes traditional copyright infringement proof impracticable. This contribution focuses on revealing how copyrighted material can be diffused and obscured through recursive synthetic data training. This article adapts the fruit of the poisonous tree, FOPT, principle to AI, proposing a new AI FOPT standard. This standard aims to address the challenges of tracing infringement in recursive AI training by establishing a framework for accountability. The AIFOPT standard establishes a rebuttable presumption of taint for subsequent AI models if a foundational model's training is deemed infringing. This contribution focuses on shifting the burden to downstream developers to affirmatively demonstrate a verifiably independent and lawfully sourced lineage or a curative rebuild. The authors developed the AIFOPT standard by specifying its trigger conditions, the nature of the presumption, and concrete rebuttal paths, such as demonstrating an independent lineage or verifiable unlearning. This contribution also addresses potential counterarguments regarding innovation and fair use. Up next, our third paper out of 5, a hierarchical language model with predictable scaling laws and provable benefits of reasoning by Jason Gaitonde and Alan Sly from Duke University. Let's break down its key contributions. The authors introduce a novel family of synthetic languages, characterized by a hierarchical structure generated through a broadcast process on trees, which enables precise analysis of context length and reasoning in autoregressive generation. This contribution focuses on an exact k-gram ansatz, which serves as a powerful analytical substitute for transformers with context length k, and the authors empirically validate its effectiveness. The authors establish a crucial omega, n, lower bound on the context length required for faithfully sampling sequences, demonstrating that sublinear context leads to significant deviations from the true language in both soft and hard-constrained settings. This contribution highlights that an autoregressive reasoning model, utilizing only theta, log, n, working memory, can sample exactly from the true language, representing an exponential improvement over traditional bounded context models. The system leverages empirical validation using transformers trained on the synthetic language, confirming both the theoretical lower bound predictions and the reasoning-based upper bound, with models quantitatively tracking asymptotic predictions. Up next, our fourth paper out of 5, Ego2 World, compiling egocentric cooking videos into executable worlds for belief state planning by Qinchuan Sheng and Shijie Li from Xi'an Jiaotong University. Let's break down its key contributions. The authors introduce Ego2 World, a novel executable benchmark that transforms egocentric cooking videos into dynamic symbolic worlds. This system allows for robust evaluation of embodied agents by providing a realistic, yet controllable, environment. This contribution focuses on a unique evaluation setup where the simulator maintains a hidden symbolic world graph, while the agent must plan using only its own partial belief graph. This design specifically forces agents to manage memory and replan without full-state observability. The system leverages video annotations from EPYC to automatically derive reusable graph transition rules that govern the dynamics of the symbolic world. This approach bridges the gap between passive video data and interactive simulation. Experiments conducted with Ego2 World reveal that persistent belief memory significantly improves task completion and reduces redundant visual exploration. This finding highlights belief maintenance as a critical area for future embodied agent research. Up next, our fifth paper out of 5, Insecure Despite Proven Updated, extracting the root VCEK seed on EPYC Milan via a software-only attack by Milan Shun and Yu Qin from University of Chinese Academy of Sciences. Let's break down its key contributions. The authors introduce the Milan Launchy attack, an exploit that successfully achieves code execution on the AMD secure processor. This critical first step provides the necessary foundation for further malicious actions. Building on their initial exploit, the authors developed the bad fuse attack, which extracts the hardware root seed. This contribution focuses on exploiting a critical lack of write restrictions within the fuse controller. The authors present a complete end-to-end attack chain that combines their exploits to compromise the system. This chain enables an adversary to forge valid attestation reports for any firmware version. This research effectively undermines the security model of SEV-SEMP, specifically its claimed capability to prevent trusted computing-based rollback attacks. The authors demonstrate that the hardware root seed, intended as the ultimate defense, is not sufficiently protected. That's all for today's AR14 CS Daily. If you found this helpful, please leave a comment, and subscribe for daily paper summaries. See you tomorrow.